Okay. Excuse me. Okay, we're doing the second half of today's lesson that we started yesterday, which is, was it 2-3? That should be 2-3. 2-3. We got to this part which talked about slope-intercept form, which is y equals mx plus b. What does m stand for? What's b stand for? Y-intercept. Now, here we're going to write in a linear equation using slope-intercept form. So you guys just told me that the formula is y equals mx plus b. What's my m value here? 1/5. What's my b value?
0, 3. No, you just want the y.
Yeah, we want the y-intercept. So which one of those two numbers do I care about? -3. All right. Okay, so we got that equation here from the information they told us. Part B gives us a graph, and we need to come up with the equation from that graph. Okay. So what two pieces of information do we need to know to write the equation down? Y-intercept and what else? Slope. So on B, can we find out what the y-intercept is? What's the y-intercept? 4. Because it crosses the y-axis right here at 4. What's my slope? Now let's see. Remember when we do slope, it's rise over run, right? From right here, I'm going down 3. So that's a -3, and it's over 1. So that's -3 over 1, which is just -3. Now that we have those two pieces of information, I can plug it into my equation. So that's going to look like what, Ephraim? What's my equation going to look like? Well, it starts off with y equals mx plus b, right? That's the equation. What's m stand for? What's b stand for? Okay, so now let's take out the m and the b and put in numbers. For part A. Part B, yeah. So part B, it's going to be y equals what? -3 x plus 4. And that's the problem for part B. All right. Any questions about what I found on those two parts? All right. All right, so here we want to write these in slope-intercept form. Remember, slope-intercept form has y equals, right? Y by itself. So what we need to do is get y by itself in each case here. Right? So to get y by itself, I need to get rid of 5x first, minus 5x minus 5x. Leave me with a minus 4y is equal to -5x plus 16. All right. First step to getting y by itself. Now what do I need to do to get y by itself? Yeah?
Does it matter if you put 16, take away 5x?
Not really. It doesn't really matter if you have the 16 first or if you put the 5x first, but we're used to having y equals mx plus b, right? So it just kind of looks better to us if we have the x first, but it's mathematically it doesn't matter if you have the x first or not. Okay? All right. What do you want to do, Yuzel? Divide by -4, and you need to divide each place. All right. Leaving us y equals, that's going to be a positive 5/4 x minus 4. A couple things about slope, right? slope is easier to deal with when we leave it in a fraction instead of a decimal number. So we want to leave it as a fraction. So we have 5/4. Leave it as that. The b value on the end doesn't matter if it's decimal or fraction, but this one right now is going to be easier for us to graph if it's a fraction. All right, over on this other side, what do we want to do first? Take away what? So that's the same thing as adding 3/4. All right, so we get a half of y is equal to, does it matter if I put the x first, Ephraim? No. Doesn't matter, but I will because of it looks better to me. All right, then what I need to do? How do I get rid of a half? I can divide by half. Dividing by half is the same thing as multiplying by what number? 2. So that will be 3/2 x minus 2. Both those are in slope-intercept form because the y is by itself. What's the slope of part A? What's the slope of part B? What's the y-intercept of part B? What's the y-intercept of part A?
17.
Oh, there we go. I finally tripped somebody up. Makes me feel good about myself. Okay, now let's talk about graphing. Okay, the reason why we like slope-intercept form is because the graphing is so nice. Okay, right here, is it in slope-intercept form?
No.
But can we change it?
Yes.
How would we change it?
Y equals. No.
Yeah. Okay. How we graph them is we need 2 points. Okay. Straight lines, you need 2 points to graph it. The first point is going to be our y-intercept. Okay. So when we graph this, the first point y-intercept. What's our y-intercept in this case? 1. So I'm going to go up to 1. Now we need one more point, right? So we need 2 total, so we need one more. The second point we get.
I have a question.
What's your question?
Why did you put a dot there? Because
That's the y-intercept.
on the y-axis.
Because we're going to use that to find the next point. All right, the second point we get from our slope. Remember, slope is rise over run, right? So our slope here is 2. What's my rise?
No, up to over 1.
Up to, what's my run? 1, okay? So from my y-intercept, I'm going to go up to 1, 2, over 1. Now tell me where to draw my second dot.
And 2 and the 1 came from where? The 2.
So right here,
2 is
this 2 is really a fraction of 2 over 1, right? Up 2 over 1, rise over run. Then we just need to connect the dots between our 2 points. And that's our line, okay? A couple things. One is this red triangle necessary? No, I just did it to be visual for you guys. It's not necessary, okay? You just need the 2 points and the line, all right, your friend?
Does this have to go through 0?
When will it go through 0? Is this direct variation? No. Direct variation is a special type of line. These ones aren't so special, okay? Dominic.
How many points, when it says to graph that right there, how many points do you need?
Whenever you have a line, you need 2.
Just 2.
Just 2.
So don't do like another set of 2 over 1.
I mean, if you do another 2 over 1, so if I go another up 2 over 1, I'm still on a line, right? So it doesn't change. The only time I like to do more than 2 points is if those points are really close together and I'm having trouble drawing a straight line. So if you do more, it might help you out to draw a straight line, but how many are absolutely necessary? 2. 2's what's necessary. Any more than that, I mean, it might be helpful, but it's not necessary. All right? Okay. Couple things about slope. Which, if I'm counting upwards, what type of number is that? If I count downwards, right, so it's positive and negative. That's the easy one. What about if I count to the right? What if I count to the left? Negative. There we go. So 2 over 1, we're always talking about going up 2 over 1. Okay, now let me ask you guys something. Is 2 over 1 the same thing as negative 2 over negative 1? What's a negative number divided by a negative number? Positive number. So they will actually equal the same thing. Now let me show you. Starting at this point, using my negative slopes, that tells me I need to go 2 in which direction? Down. And the negative one tells me I have to go back, right? Did that get me to the same spot? You might use those every once in a while, doing it like that, if like, you know, if you needed to go backwards to find slope. Yeah, Dominic.
So say you started at a point 1, the 1 right there, could still do something.
Yeah, down 1, 2 over 1. No matter how many times you do it and which direction you go, it'll always equal the same thing. Always be on that line. Okay. That's your homework assignment. All right. We have half hour or so to work on it.